factorization helps us solve a lot of questions, and the whole process of factorization in the numbers part, which will come as a little bit different from what you have done in school and college. This is one part, though the idea is still very much the same, what we know, HCF, LCM and all that stuff, but the approach is slightly different. For example, say if you take a number 36. Now 36 we know can be written as 4 into 9, which can be written as 2 square into 3 square. This is what we call prime factorization. Prime factorization means that you write the number as a product of prime numbers only, 2, 3. I'm not writing 4 or 18 or 6. And then how do you write the number properly as product of prime numbers? Whatever be their respective power, you give it to the number. For example, say 60. 60 can be written as 6 into 10, right? Or 20 into 3, no. We will write 60 as 3 into 2 square into 5. Right? This is called prime factorization. Let's take any other example, say 800. So 800 is 8 into 100, which is 8 into 4 into 25. So it can be written as 2 to the power 5 into 5 square. Right? I hope we have all understood what prime factorization means. You write the number as a product of prime numbers with their respective power. So the numbers that you will write, which constitute the original number, they should be prime numbers with their respective power. And with a little bit of practice, you will realize this is not very difficult to do. This is something, that will come in easily. Obviously, you may not be able to write it in one shot, but for example, the way I did in 800, I wrote it as 8 into 100, and then you can subsequently write it as a product of prime numbers. Okay. Now this is very, very useful for us to calculate a lot of other things. The first thing that we will try to calculate is the number of factors. That is, how many numbers are there which will divide our number completely, remainder 1. This is what we call a factor. So how many factors does a number have? Let's take a number for which we can calculate the factors easily. Say 36. Let's write down the factors without using any formula. So 1, 2, 3, 4, 6, 9, 12, 18 and 36. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Now 36 we know the prime factorization is 2 square into 3 square. Now you see how we get the number of factors. Number of factors is equal to power of the first prime, which is 2, plus 1. Remember, we are not dealing with the prime number itself, it's power only. Power plus 1 multiplied with power of the next prime plus 1. Since there are only 2 prime numbers, therefore we write only 2. If there would have been one more prime number, another power plus 1 would have come here. So how many factors will 36 have? 9 factors. Right? Say for example, say 90. 90 can be written as 2 into 3 square into 5. So number of factors of 90 will be power of 1, 2 and 1. So the number of factors will be 1 plus 1, 2 plus 1 and 1 plus 1, which is equal to 12. So 90 will have 12 factors. For example, say any huge number, 2 to the power 5 into 3 to the power 4 into 5 to the power 7 into 7 to the power 3. How many factors will this number have? 6, 5 plus 1, 4 plus 1, 5, 7 plus 1, 8, 3 plus 1, 4. This will be the number of factors for this number, which comes to 960. Alright, we understood this, how to calculate the number of factors, but this is only the tip of the iceberg. Using the prime factorization method, there are a huge number of things that we can calculate. So number of factors, I hope it is clear. And how do I practice it? Just take random numbers. If you take random numbers, say any numbers, 248, try to take even numbers because it will have at least 2 as a factor, so it will make your job a little easy, because last thing you want to do is end up with a prime number which has no factors and you are rocking your head against it. So say 248. Then you try to do prime factorization, right? That practice, and once you do your prime factorization properly, you try to find the number of factors, okay? So this is how we can practice it. Next thing in this whole thing, extending that, will be sum of factors. So I know my number has X number of factors, but what is the sum of all these factors? What happens when I add up all these factors? Okay. Say 36. Let's take 36 again because this is the number we have been dealing with. 2 square into 3 square. So the number of factors is 2 plus 1 into 2 plus 1, 9 factors. Right? What happens when I add up all these numbers? All the factors, 1, 4, 3, 9, 6, 18. What happens? What is the sum? Is there some pattern to it, some method by which I can get the sum easily? There are two ways to do it. First method goes like this. 2 square, right? 2 square. So take 2 to the power 0 plus 2 to the power 1 plus 2 square. Which means you take the power of 2, keep on adding them till you reach 2, till you reach the power which is there. Same thing you do with 3. So 3 to the power 0 plus 3 to the power 1 plus 3 to the power 2, and your answer will come as 91. Okay. Another method is, it goes like this. 2 square, so take 2 square plus 1 minus 1 by 2 minus 1. Alright, so this is kind of a formula. Let's understand this, what I have written here. 2 square, so 2 square plus 1, so 2 to the power 3 actually, minus 1 fixed for any number. Then this 2 is basically the prime number 2, 2 minus 1. For 3 also we'll do this. So 3 square plus 1, which means 3 to the power 3, minus 1 by 3 minus 1. Alright, now if you solve this, you will get 91 again. So this is how we get the number of factors. Alright, okay. The next thing that we will do is co-prime numbers. Co-prime numbers. First, let's understand what we mean when we say co-prime number. Co-prime has got nothing to do with prime numbers. Co-prime means two numbers which have no common factor. Their highest common factor is 1. They don't have a common factor. That is what we call a co-prime, pair of co-prime numbers. Alright. So what we are trying to find here is how many numbers less than that number are co-prime to that number. Okay. For example, say 12. Right. Now how many numbers are less than 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Let us see how many of these numbers don't have a common factor with 12. 1 is a factor of 12, right? 2 is a factor of 12, 3 is a factor of 12, 4 is a factor of 12, 5 is neither a factor of 12 nor it has got anything in common with 12. 6 is a factor of 12, 7 is not a factor of 12, also has got nothing in common with 12. 8 is not a factor of 12, but they have a common factor, 4, also 2, so we won't count 8. 9 is not a factor of 12, but it has a common factor with 12, which is 3. 3 divides 9 as well as 12. Same goes for 10. 10 is divisible by 2 as well as 12 is divisible by 2. 11 is another number which is co-prime with 12, no common factor. Okay, so we got 3. But in this case, we also include 1. So 1 is taken both as a factor as well as a number which is co-prime to that number. Therefore, how many numbers less than 12 are co-prime to 12? We got our answer as 4 by counting. But is there a formula? Yes, there is. Always. First we prime factorize 12, which is 2 square into 3. Right? In this case, we will focus on the prime factors, which are 2 and 3. So it goes like this. 12 into 2 minus 1 by 2 into 3 minus 1 by 3. Which if you solve, you will get 4. Okay? Say for example, any number if we take, say 54. 54 can be written as 2 into 3 cube, 27 into 2. So number of co-primes less than 54. Less than 54 but having nothing in common with 54 will be 54 into 1 by 2 into 2 by 3, which is equal to 18. So there are 18 numbers less than 54 which have no common factor with 54, are co-prime to 54, which means there are another 36 numbers which have a common factor with 54. And just as again as a reminder, 1 is taken both as a factor as well as a number which is co-prime to that number. Okay. So what have we completed till now? We learned how to do prime factorization 1. Using that, we learned how to find the number of factors 2. And then we learned how to find the sum of all these factors 3. And fourthly, we have done till now how to find the number of co-prime numbers. Right? Co-prime numbers, we'll learn one more concept here. I know that a particular number has X number of co-prime numbers less than it. But what happens if I add up all the co-prime numbers? We did 12, so let's take the example of 12. We got 1, 5, 7 and 11 as co-prime numbers, right? Now you see something. 1 plus 11, 12. 5 plus 7, 12. Does it always work? Let's try. Let's take another number, say 18. What are the numbers co-prime to 18? 1, yes, 1 is co-prime to all the numbers as we saw. Not 2, not 3, not 4 also, no, yeah, 5. Not 6, 7, yes. 8, no. 9, no. 10, no. 11, yes. 12, no. 13, yes. 14, no. 15, no. 16, no. 17, yes. Now let's try to see if this works for 18. 1 plus 17, 18. 5 plus 13, 18. 7 plus 11, 18. Which means if a particular number has x co-primes less than it, you can form x by 2 pairs. X by 2 pairs. You can pair these co-primes and each pair will give you the sum as the number itself. Therefore, if I add up all the co-primes, what do I get? Say a particular number has x co-primes. Then the sum of all this x, if I add up all the x, what do I get? N by 2 into x or x by 2 into n, whichever way you want to look at it. Right? For example, 60. Let's take the example of 60. 60 can be written as 2 square into 3 into 5. Number of co-primes 60 into half into 2 by 3 into 4 by 5, which will give us 16. So there are 16 numbers less than 60 which are co-prime to 60. What is the sum of all these numbers? 60 by 2 into 16, 480 is the answer. Right? Okay. Now using this we will do some more things in the next module. Thank you.